starters, let's go to Blackboard. Let's download some files that are on Blackboard. There's going to be some SPSS files. Those are the files with PostScript.sav. There's going to be some Excel files. And there's also going to be some files that have .csv on the end of them. Those are comma delimited files. Between each field of data, they have a comma in between. We're going to play around with each one of those things. We're going to look at how they're interchangeable. We can move those files from program to program. What I'm hoping to do today is to take a look at SPSS, explore SPSS, and to start doing some work, some useful work with SPSS, and perhaps making some of the data summaries, some of the tables and charts that Levi was demonstrating upstairs in the lecture. So for starters, let's go to Blackboard, because I'm going to need to download them to this location as well. Just so you know, normally we're in C09, but they had a class in there that was running long, so I didn't get a chance to get set up. Problem number one. Problem number two, I normally use my Mac and a built-in mic and stuff like that. Unfortunately, they haven't managed to get SPSS installed on my laptop, so I can't download this stuff on my laptop. Normally, we'd be a little bit more mobile here. And it kind of like set me back a little bit. So you may see me stumble a little bit as I use the PC, because I'm not that used to using a PC. I do at work, but I try to avoid it as much as I can. So I'm going to go to Blackboard, and I'm going to download those files as well. I'm going to drop them on the desktop so I can manage to work with them. And you guys at home can do the same thing. And let's see, why don't I see my... Here we go. This isn't going to work out so well. I need a better angle. Okay, let's go to the lab. Oh, while we're here, I'm going to bring this up later on. I just want to point it out for right now, and I'll bring it up and demonstrate it later on. I made a specific tab over here for tutorials. I have it here in a folder echoed here, help from the web. And what these are going to be, they're going to be links to various tutorials that are on the internet, hopefully free. Some of them cost a few dollars, but most of them are going to be, most of the ones I'm aiming for are going to be free. They just made an announcement that Hunter has made some, CUNY actually, has made some sort of arrangement with lynda.com. You guys ever use lynda.com? Anybody here? It's basically an online learning site. It's not like a college. It's not like edX or Coursera or something like that. It's not an online college. But what it is it's a number of professionally produced videos on everything from Photoshop to business applications to Excel to SPSS to many, many, many different applications. A lot of stuff that you're going to find interesting. But among other things, it has tutorials, very good tutorials and videos on SPSS, R, and Excel, the software that we're going to be using. Only downside is it's not available by proxy. You can't get to it from off campus. You have to use the computers down at 68th Street. But it's free. You can subscribe to it. It's like $35 a month or something like that. But that can add up if you month after month, especially if you're like me, you forget to turn off the subscription, right? So and then you don't use it for 6 months or something like that. So you might want to consider that, because dropping up there, maybe spending a few hours. For instance, the introductory R course is probably like 3 or 4 hours of video, but it's something that you could sit down there and do in a session or so, have a little snack. Well, they won't let you eat. They won't let you get away with eating in the labs down there. You can up here a little. They're not looking over our shoulder quite as carefully. So that happens to be a really good way to learn some of these applications. There are also free courses on edX and Coursera.com. Okay, and that might be .org. I'll put up some links to it. And they have a number of courses in R and SPSS, some introductory, some a bit more advanced. But I'll put links up to them, and those are free. You can register for them. Some of them have a dedicated start and end time, but many of them are online all the time. You can jump in. You won't get the advantage of the feedback on courseware and homework and stuff like that, or exercises that are on there. But you will be able to go through all the videos and learn about these different applications. So we'll take a look at that in a little while. In the meantime, let's download our files. So I'm going to go into session 2. Okay, what I'm going to do here is I'm going to start with this NC Birth 800 file. I'm going to right click on it. I'm going to say save this link as. I'm going to drop it on the desktop so I have access to it. I'm particularly clumsy because, and I'm going to take the Excel version of it, of this descriptive statistics file. Save link as. I'm going to drop that on the desktop also. On the desktop, I'm on there already. And let's see, Excel to SPSS, Excel file. Oops. Right click, save link as. Again, drop it on the desktop. The reason why I'm looking so clumsy here is that I'm trying to do this sideways. And mice were not intended to be used sideways. Okay, I don't see any complaints from the people online, so they must be keeping up with this. There are 2 documents over here that are basically kinds of exercises. I'm going to download this first one right now onto the desktop so it's accessible to me later on, and I'm going to leave that PDF file up there for now. Okay, so let's open up SPSS. I'm going to see if I can find it here. I don't see it. Maybe hidden under IBM SPSS. Anybody see it there?
It's right there.
Did I miss it?
It's right there.
Oh, there it is. Okay. There we go, finally. Things been a little hectic for me this week. My day job is being a consultant on water systems, especially cooling towers and things like that. So as you can imagine, things have been a little hectic for the last couple of weeks. The Department of Health, well, let's open up. The Department of Health had a meeting on Thursday, and they invited all the water treatment contractors and consultants that are involved in this kind of work, and presumably for a session where they were going to discuss the new guidelines and the new local law that they're publishing for disinfection of cooling towers and control of Legionnaires' disease. And they got a packed room there. They had about 50 people on a conference call as well. Once they got everybody into the room, the first thing they said is that all of you guys can expect to see subpoenas because they want records on every one of the cooling towers everybody has ever touched in the last 2 years, any one of those consultants. So we have to turn over all our files on our customers. So it was basically the biggest ambush since the OK Corral. So a little bit of a surprise. So you can imagine that's made things a little hectic. And it's 5 days to respond. So they're nuts. They really have gotten crazy. Well, you know that you've read that the city gave every cooling tower in the city 2 weeks to do a disinfection, right? And there's only 6 or 7 companies that do this kind of work. So anybody have any experience with Legionnaires' disease that work or healthcare centers or something like that responsible for maybe testing, right? Anybody do any environmental testing here? No? Okay. Interesting field. Going to be more interesting going forward. Okay, so let's take a look at this first of all. Yeah, you probably have it open on your screen now as well. So let's run across the menus here, these drop menus, and see what we have. This is a standard file menu. You know, you can save open data files, save files. We have a couple of extra selections here, like for instance, when we go to open, we can open a data file, we can open a syntax file, we can open an output file, and so on and so forth. The main deal here is SPSS works with more than one kind of file. Okay, Excel, you work with that one spreadsheet, that one workbook or spreadsheet that everybody's familiar with. SPSS is a little bit different. It has a data file where it stores all the information, all the patient information, all the variables, all the information about the nature of the variables, and so on and so forth. That's all stored in one file. It uses it in one file and in one window. It's shown in the window. And in fact, in the background here is that it opens up a new data window, so you can actually start typing in data if you wanted to right now. When you perform an operation with SPSS, anything, whether you open a file, whether you save a file, whether you do an analysis, whether you produce a chart or something like that, it takes the output that you're looking for and opens a new window and posts that in the new window, and it accumulates that. It scrolls up almost like one of those adding machines with a paper tape on it. So you're continually, as you do analyses, it just adds one onto the bottom of the next and the next and the next. So you have a record of all the analyses, all the work that you've done in that output window. Okay. Now, when you save your work, you go to this file menu, you say save as. You got to remember that if you say save as and you're in this window, the data window, you'll save your data, but you won't save any of the analysis or charts or anything else that you made. If you want to save them, you have to also then open the output window, and we'll see that as we work through this. And you have to save that window as well. Now, there's a third window, there's a third type of data file that is listed here, and that's syntax. Syntax and script are kind of similar. Anybody know what syntax means or script means? What does that refer to? Any programmers here? Any coders? Right, you guys are in the wrong field. Everybody wants coders now. They don't want MPHs, right? You guys, anybody here know a coder? Somebody that professionally codes, right? You do. Have they ever told you what work is like? It's like you'd want to stick a fork in the eye. It's the most boring work in the world. They're like, if you go into a major software house, it's like literally like a sweatshop. You know, guys lined up. I mean, it looks very romantic. You know, they have toys out and razors. And if you go to Google, they have slides and massage tables and stuff like that. Nobody's using. I've worked at Google. I've worked doing environmental work for Google. Nobody's using any of that stuff. Maybe every once in a while they're using it. What they're doing is sitting at their desk and coding all day. And I mean, they really work them. You know, they really expect some real output for them. I'll give you an example. At the urinals at Google, they post up sample code. So while you're in there, you can like learn a few things. You know, that's the absolute truth. So anyway, don't worry, you don't want to be coders. There's a little bit of money in it, but you don't want to do that kind of work. It's terrible. You're doing much more interesting and valuable work than they are. So at any rate, okay, so let's see, we have three. So script is basically coding. You can program SPSS. You can give it instructions, very English-like instructions to do these analyses. And in fact, you can use that script instead of using these drop menus. For the beginning, we're going to use these drop menus. By the end of the semester, maybe we'll get to the point where we feel comfortable enough that we want to actually learn how to use some of this script. And the reason why the script might be as important is because very often in real life, you may find yourself repeatedly doing the same kinds of statistical analyses with new data or importing new data or merging new data and so on and so forth. Yes?
So would that be so much like if you wanted to code or take information, say, from like, say I work at a hospital for like medical records?
Yeah, kind of, yeah. Because you would, well, you'll see what the script looks like. Okay. You get an idea. In fact, what it does is as we work with this, you're going to see that it's actually going to show you as you work with it what the script would look like to do the operation that you just did. So if you want to repeat it, you can just copy that and run it again. Okay, so anyway, so we have the regular file menu, print, so on and so forth. We have a view menu to view various kinds of, to hide or show status bars and so on and so forth. We have a data menu to define variables and properties. We're going to see ways to do that so we don't have to wind up using this menu as much as you might think. We have a transform menu. Now, this one's kind of special. This menu allows us to take variables and operate with them, work with them, do calculations with them. Like, for instance, let's say we have a variable weight and we have a variable height. We can create a new variable called BMI, and we can actually have SPSS take this transform variable, create that new variable BMI, and actually do the calculation for each person for us, right? So we're going to take a look at how that works as well. So we can actually also, we can have SPSS create a new variable that filters certain kinds of data so that that kind of data now is excluded or transformed into something else, into another more usable form, and into a new variable. But we're going to take a look at that as we go forward. Analyze, this is where we're going to, as you would think, this is where we're going to do most of our actual analytical work. We're going to do most of our calculations. Okay, what do we have here? Let's see, we have descriptive statistics. We have, under descriptive statistics, we have, as you would guess, frequencies, right? Just simple counts. We have descriptives, means, medians, and so on and so forth. We have something called explore, which is really descriptive statistics with like a little bit supercharged. We'll take a look at how that works. We have something called crosstabs. Crosstabs are basically how you would build tables, you know, columns and rows. And you'll see we use those quite a bit. We have a whole bunch of, we have other things that maybe we'll get to, maybe not. Down here we have compare means, right? Later on we're going to learn that there's some kinds of statistical tests that we use for comparing means. One of them is something called a t-test. Many of you probably had a little bit of experience with that. We have, I'm going to go down here to, we have, we can do correlations. We can compare two numerical variables to see if there's a correlation association between them. We can do something called regression, okay, which we're going to get to towards the end of the semester, which analyzes two variables that may be associated and tries to quantify that association. So there's a lot of stuff we're going to be able to do here and analyze. A lot of this stuff we're not going to get to, a lot of it we are. Okay, now we want to display statistics, very frequently we want to display statistics graphically. We saw what an advantage was when we were looking at that demonstration of population, of life expectancy and birth rate, fertility that we were looking at last week. And we have a whole series of utilities and so on and so forth. So for now, that's really what we're going to be working with. So let's take a look at this table right here. It looks very much like Excel, right? Got columns and rows, except the rows, except the columns. Let's see, I'm going to go back over here on this. That's actually my data view. Right now, there's nothing in this table. So it has this little grayed out three-letter word VAR for variable. So each one of these columns represents a potential variable. Okay, could be, this first one could be gender. Second one could be blood pressure. Third one could be weight, and so on and so forth, right? Each one represents a variable. So I'm going to type in some data right now. You might want to give this a try too. I'm going to assume that this first one represents gender. Now, a lot of times if I type in a male here, and I go down here and type in male here, okay, as far as this computer is concerned, those are two different things, right? It's case sensitive. So those are two different things. I won't see them the same. And we have to actually physically type out the word. You can have misspellings, you can have errors and stuff like that. So it's not uncommon to use numbers, even though this is what kind of variable is this? Categorical nominal variable. Even though it's a nominal variable, we can represent it with numbers. I'm going to call males 1, and I'm going to call females 0. 1, 1, 1. I'm going to put 10 people in here. 0, 0, 0, 0, 0. Okay, notice since we didn't tell SPSS what this variable was, right? It made up its own variable name, VAR 00001. SPSS variable names variable names can have up to about 20 or 26 letters, I think they are. They're pretty long. They can be numbers and letters, but they have to start with a letter. They can't have any spaces or special characters. I think the one thing, they may tolerate underscores, but I think basically anything else it doesn't tolerate. Okay, so there's a few rules about that. So in here, I might put, whoops, didn't mean to do that right now. I might want to change that into a variable named gender. Okay, so now to work with that variable, to define that variable for SPSS, to tell it what that variable is, to change the variable name, I have to go to a version of this page where I can see how this variable is described. And if you go down here, you see that there's a tab on the bottom that says data view and variable view. Within this same window, we have two views. We have a data view we're in right now, and we have a variable view. The variable view, each column in the data view is now represented by a row. Okay, so right now, here's our variable. Our variable name is VAR00001. Okay, so I'm going to type in there, and I'm going to change that to male. I'm going to change that to gender. Okay, now a lot of times variables are going to be a little bit harder to describe. You may code them, may give them letters and numbers, and so on and so forth. Maybe a little bit more complicated. But for now, I'm just going to call this gender. I'm sorry. Yes.
Mine has decimals. That makes a difference.
It doesn't make a difference. There, you can define. You're going to see why that happened. Okay. As I go across here, that column now represents gender. If I go back there, you'll see there it says gender at the top. And ones are males and zeros are females. I'm going to go back to variable view. So what kind of variable is, what kind of like input is this? It's a string, in other words, letters. Okay, I can change that to numbers if I really want to work with, if it were a numerical variable, but it's a string variable. It could be letters, numbers, and so on and so forth. It usually probably would default to numerical here because it's sort 0 and 1, but probably somewhere else in there I typed in a space or something like that. So I wouldn't worry about that too much right now because as we go on, we're going to define that better. The width is the width of the variable. Okay, so at 5, we really only need a width of 1, but I'm going to leave it at 5. Doesn't matter. How many decimals do you want this variable to have? Well, I can go in here and I can change that to any number of decimals I want. That's why some of you are seeing a couple of decimal points after your ones and zeros. Since ones and zeros are pretty much interchangeable, we wouldn't have to worry about that. Notice it's not too, if I had made this a numerical variable, if I had told it was numerical, I think what's going to happen, it's going to look a little bit differently. Okay, now it says numerical. Now if I click in here, notice when I clicked in here this time, I got a little arrow, the little set of up and down arrows. So I could change in here and change it to how many decimal places it has, or I could just simply type it in. Okay, so it automatically saw that SPSS understood and recognized the difference between a number and a letter, the letter 1 and the number 1. Okay, for our purposes, we don't care because we're about to tell it that this is a nominal variable. Okay, now let's say that gender, we want a longer description of gender. But we can't, but we want it to have spaces, so it makes sense if we're going to produce a report or a table or something like that. So instead of gender, I might want all of my reports or outputs to look something more like, let's see, sex of patient, right? Now that would be inappropriate as a variable because it has spaces in it. Wouldn't be able to use that as a variable. But now that I've put it into this label category, whenever SPSS uses the variable gender to produce a table or a chart or do an analysis, the output is going to say sex of patient instead to make it much more intuitive for someone that's going to read the table. Make it easier for you too, because then you can take that output and use it in other locales. Okay, now values. Now this is an interesting one. This doesn't get used for numerical variables because the value of a numerical variable is just the number. But the value of our nominal variable, when we gave it a number, means something, right? Like what did the number 1 mean? What did I say number 1 meant? Male. So I'm going to put a 1 in there. I'm going to say male. And I'm going to click add. Okay, I'm going to put the number 0 in there. And I'm going to go into label. I'm going to say female. And click AL. Add. I'm going to click OK. Okay, so now we have values for that. You only use this really for nominal variables. Okay, so now let's say there's missing data, right? What do we want SPS to do about missing data? So there's a few things you can do here. You can define missing data as having a certain value. Now, gender is typically going to have 2 values, male and female. I might define the number 9 as, instead of putting just a blank space, I might put the number 9 in there for a missing variable. Or, I might even want to define certain variables so that if they refuse to say whether they were male or female, we put an 8. If they didn't know if they were male or female, we put a 9. If they, so on and so forth, who knows you can translate that into a real scenario, but you can define for SPSS what represents a missing variable and how to handle it. So, but most of the time, we're not going to worry about that too much. Okay, so now we can talk about the number of columns. This is the width, the maximum width of the variable is on the width. The width that's displayed in the window is this width. And then you can tell SPSS if you want to align that variable to the left or right or center it. And then also, let me see if I can get this out of our way. Okay, and then we can go in here and we can tell SPSS what kind of variable it is, and it recognized it as a nominal variable. It knew it because it automatically, that was originally probably numerical, but it recognized when I went into the label that it must be a nominal variable. So in fact, if it gets it wrong, you can correct it. Okay, now we've defined a number of different kinds of variables. Okay, we've defined numerical, discrete numerical, ordinal, and so on and so forth. SPS sticks to 3 basic data types. Okay, say scalar, which is numerical. Ordinal, we know what ordinal is. It's a scale, an ordered scale, and nominal. In this case, we're sticking with nominal. And this is just going to say that this is an input variable. So let's go back to our data view. See how that's changed. It's showing decimal points here because I put the decimal points in, but it still recognizes this is 0 and 1. If I go up here to view, right, there's a line down here that says value labels. Remember we defined those values as 1 for male and 0 for female. If I click that, okay, it substitutes the value for the number. So I can actually see what that is if I don't want to remember it particularly. Okay, so I can go back. That's a toggle. Whenever you have something that each time you hit it changes, you refer to that as a toggle. So there we are. It's ones and zeros. I'll go back and leave that turned on. Okay, and all of this is within these 2 windows. And we can have any number of other kinds of variables. I'm going to just make up a bunch of numbers here. I'm going to say weights or something like that. So I'm going to pick out some numbers that I think might be reasonable for male weights and for female weights. Okay, and for female weights. Okay, and that's a numerical variable now. And again, I can go back and define and give it just a variable name. Notice it says here measure unknown. I'm going to tell it it's a scalar variable. And that's going to be important to us because SPSS will only allow you to do the analyses that would be appropriate to that variable type. And I'm going to call this weight. And numeric, and we're not going to use any of these other things. Okay, go back. Okay, so now let's take a look at some of the analyses that we can do with this information. Okay, I'm going to go up here to, and since we want to do analyses, I'm going to go up to Analyze. And I'm going to go down here to Analyze, and I'm going to go into Descriptive Statistics. And the first thing I'm going to do is I'm going to go into Frequencies. Let's get a count. Okay, so now frequencies are counts how often something occurs. So for numerical variables, frequencies don't really make any sense, do they? Because there may not be two numbers that are exactly the same within those weights, right? So frequencies don't make a lot of sense for that. But for gender, frequency makes some sense. I'll know how many males there are and how many females there are. So let's tell SPSS by moving this from our variable list, moving gender from our variable list into our variables that we want to work with. Let's tell it that we want to do a frequency count for gender. And there's the number of things I can do here. I can do various statistics and stuff like that. Now, one of the things about SPSS is very powerful statistical software. It's easy to do something inappropriate. It's fast and easy and quick, but you can do something inappropriate. Like, for instance, finding the mean of males and females really doesn't make any sense, right? It's not a numerical variable. Okay, and so I'm going to put gender in now. I'm not going to worry about this too much. I'm just going to click OK. When I click OK, it's going to produce some output. It's going to give me a table with frequencies. When it does that, it's going to open that new window for us, the output window. And there's our output window. Okay, if I go up here to window, right, now there's two windows open. There's my untitled, I didn't bother to save it, so there's no title. There's my untitled data window, and now there's a new window, my output window number 1. Okay, and there's my output, right? So what is it telling me? It tells me the frequency is there's 5 males, 5 females, 50% of the population is male, 50% is female, and so on and so forth, and there's no missing values, right? See over here, 10, and no missing values. Okay, so that's pretty interesting. That's obviously, this is a simplistic way of looking at it, but we're going to get into some examples of this that are going to be a bit more challenging. While we're here, let's look at graphs. Let's go down here to graph. There's a variety of ways of producing graphs in SPSS. Okay, there is a chart builder. It's kind of like one of these macros that you see that Microsoft likes to use, where you can go through a series of steps to create things. There's various other ways to choose type of graph and template. I'm a legacy, so I like to use the legacy dialogues. So I'm going to go over here to legacy, and I'm going to go down to, let's see, you probably would do a bar chart with something like this. So I'm going to do a simple bar chart. Summarize groups of cases. Let's say define, and let's see. We're going to put the gender into, oops, category axis. I think this should work now. Let's see if that works. There we go. All I did was just simply move that data over into the field that had the height of the bars. So there's 5 males, 5 females. Simple enough, right? My bar graph. So here we are, we're able to, and notice now, if we hadn't changed the variable name, we would have had VAR 0001 on the bottom. And if we hadn't used the label, we would have had gender down there instead of sex of patient. Okay, so that makes it a little bit easier to use this. Now, what good does this do? Well, any of these tables or charts, if I click on them, I can right click on them and then I can say copy. I'm going to open up Word if I can get it here. I hope this program's listed there. No, I can't read that from this angle. Microsoft Office, Word. Okay, and I go in here, and I can say paste. I'm going to do it this way. Let's see. I'm going to say paste. I'm going to do it a few ways. First, I'm going to say paste from this ribbon, and I paste the table in. Okay. Then I'm going to go over here. There's a little down arrow over here on the bottom of paste. Can you see it there? It's kind of hard to see. I'm going to click on that. It's going to give me some choices, and I'm going to choose paste special. Okay. Now it gives me a few extra choices: unformatted text, formatted text, so on and so forth. The Word isn't installed properly here. When it's installed properly, hopefully on these computers here or on your computer at home, one of the other choices that it will give you here is a choice of pasting it in as a picture, as a JPEG or some other graphical form. Right now, for us, for this table, not a big deal. However, imagine if this table were 7 columns wide and 100 columns long and so on and so forth. And when you paste it in, it just extended off of the table. By clicking here, look at all these tabs up here. If we had to like kind of resize this to fit into the page, we'd be here all day. So sometimes it's better to paste it as a picture so you can resize it and move it around very easily. So when you're at home or you're doing homework or something like that, see if you don't have that paste special option so you can paste it in as a picture. Let's see if it works. Maybe it doesn't like that table. Let's try it for this. Copy. See if copy special. Oh, okay. You know, might be turned off. Maybe this will give me a chance to do that. Copy. Maybe a copy was bad. Okay, I'm going to go to Word. And actually, this is going to paste this in by default as a picture, right? Because it is an image. And when it's in there as an image, you can, of course, resize it, move it around. Let me do the table again. See if that turned on, being able to paste it with a table. Copy special. Okay, turn on JPEG and image. Usually those are on by default. Oh, let's do that. There it is. It is now. Let's say again, copy. And now I'm going to go to Word. And now I'm going to go in here and I'm going to say paste special. And no, it still didn't did it. Nope. Yeah, there's something wrong with the install on this. It's just not giving me the option. Okay, but like I said, this would certainly be easier if I could handle this as a picture, right? Maybe not sometimes, maybe not other times, and so on and so forth. But this is valuable, right? Now you have a way to create tables, charts, statistics for all your other classes. Just come in here, use it, take your data set, produce a relatively more complicated chart than this. Let's take a look at another design. Let's see. And again, now we're in the output window, right? If we want to get back to our data, go back to the data window. Okay, and if we want to save this work, we would go up here and say save as, right? And it's going to save it under a file name that you give it .sav. If I was about to do the same thing with the output window, I would say save as, and this window is going to save as something called an SPV file, .spv file, and you can give it a separate name. If you save only the data window, you won't have the output file anymore, and you'll lose all those graphs and pictures that you've produced. Another thing that you can do is you go up to File, if you want to preserve them, and you can say Save As, and you can choose to save it as a rich text file. Oops. Oops, I can't get to it. Viewer file, that's not it. Again, the install here is a little wacky. On your version, one of the choices should be a .rtf file, which is a rich text file, which basically is kind of a Word file. So all those tables and charts will be saved in that rich text file. Okay, or you could just save the output window. The only downside of this is that if you're doing homework or something else, you can't send me, you shouldn't send me .spo file, that output window file. Because SPSS, the data files, the .sav files, pretty much interchangeable. The .spo files sometimes can be hard to open between versions, older versions, newer versions, Mac, PC, whatever other versions that there might be out there, right? So it's better if you take that and copy it into a Word document when you're doing your homework. But I'll give you some guidelines on that as we go forward. Okay, so let's see what else we can do with this. Now I mentioned that this is really an appropriate data type for us to do descriptive statistics on, beyond a simple frequency count. Let's do descriptive statistics on a variable that we can work that way with. I'm going to go back to my data window. Now you don't have to go back to the data window. That menu is available to you whatever window you're in. But I'm going to just go back here just because I feel comfortable that way. I'm going to go to Analyze. I'm going to go to Descriptive Statistics, and I'm going to go to Descriptives this time, next choice. Okay, so now I'm going to ask it to produce descriptive statistics for me. Okay, now again, gender, I know I don't want descriptive statistics for because the average of male and female is not going to make it, unless I get, what would it be? One testicle and one breast, right? I don't know what an average female and male would be, right? So I'm going to move, I can't use that. I'm going to move weight in there, right? So if I move weight in there, I have a few options. I can tell it that I want it to calculate the mean. By default, that's turned on. The standard deviation minimum, we played around with this a little bit last week. I'm going to check out variance also and range. I'm going to stay away from the other stuff because we haven't covered it yet. And I'm going to say continue. And then I'm going to say okay. And it's going to analyze the variable I put in there, which is weight, numerical variable. Notice it shows a ruler for a numerical or what it calls scalar variable. And it shows red, like red socks, blue socks kind of thing for gender, which is a nominal variable. I'm going to click OK. So a window, as we would anticipate, our window pops up again. And I'm going to do this. I'm going to do this twice. You don't have to. I'm just going to do it a couple of times because I wanted to scroll up so you can see it. It's going to remember what you did from selection to selection. So hopefully you can see that on your own screens as well. So what do you got? You got 10, your sample size is 10. Your range is 78. That's the highest number, the highest weight to the lowest weight difference. The minimum is 133. The maximum is 201. You can see that. The mean is 150.9. Standard deviation is 24. And the variance is 579. So I have a table. Again, I can take this table, I can paste it into another document if I want to. Okay, so that's interesting. The mean is 150.9. What is that the mean of? That's the mean of everybody, right? It didn't really give me a choice to separate males and females out, right? So, and it didn't do all the statistics I might want, right? It did most, but it didn't necessarily do all of the statistics I might be interested in. Okay, so I might want to take a closer look at this and maybe separate these variables out. So let's take a look at the next option that we have over here. Analyze, descriptive statistics, and I'm going to go down to explore. Explore is the same thing as descriptive statistics, except that it gives you an opportunity to do a bit more with the data. Again, this is descriptive statistics, so I'm only going to do it for weight, not appropriate for gender, nominal variable. And however, it says that there's a factor list I can put in here. What does factor mean? When you factor a number, you're breaking it up into its components. Like if you have number 12, you factor it into 3 times 4, right? So factor is something that's going to factor it or break it up into groups. So the groups I want to break it up into happen to be gender. So I'm going to move that into my factor list. So just to keep in mind that whenever you do this, the numerical variable goes in the top, the dependence list, and the nominal variable, the groups, go into the factor list. Okay, I'm not going to worry about labeling the cases for now. Now, notice I got a whole bunch of options here. I can create statistics alone. I can create plots or graphs, or I can create both. I'm going to leave it on both. I also have a bunch of option buttons here. Click on statistics, and it's going to create as many descriptive statistics as I want. It's going to create something called a confidence interval, right? Which typically might be a 95% confidence interval. Some of you guys may remember that. Don't worry about it if you don't. By the time you get out of this course, you'll be sick of confidence intervals. Okay, and some other options. I'm just going to leave descriptive statistics turned on. Under plots, it's going to, now, as it happens, it's not obvious here, but as it happens, it creates box plots by default. It's going to create a box plot no matter what we do. But I can ask it to do, and a stem and leaf plot. I'll describe that in a second. But I'm going to tell it, make a histogram up while you're at it. Make histograms up. They're not going to make much sense with only these 5 pieces of data in each group. But we'll at least get a look at it. We'll at least be able to convince ourselves that this actually does work. Okay, and I'm going to click continue. And there's a few other options that we don't necessarily have to worry about right now. Okay, once I'm done choosing my options, I click OK. Okay, and bingo, look at all this stuff we get. Okay, let's see what we have here. First of all, we got our typical counts, our cases, how many males, how many females. We have our descriptive statistics, and they're separated. Okay, weight is our variable, numerical variable. The top half of this thing represents the statistics for the females. The mean for the females is 134. The mean for the males is 167. 95% confidence interval, median, variance, standard deviation, minimum, maximum, range at the quartile range, skewness, so on and so forth, all the stuff that we were interested in that wasn't in the descriptive statistics. So this explore function has a bit more power and versatility than descriptive statistics, but it's still descriptive statistics. Okay, if I scroll up further, let's take a look at the plots that it made for it. It made a separate plot for us for males and for females, right, by gender. Made a stem and leaf plot. The way the stem and leaf plot works is that the 2 points, you got 2 points here, let's see, frequency. This is for females. The first 2 digits, one of the females was 123 pounds. That was the lowest number, right? One of the females was 123 pounds. The way it represents that female is it puts a 1 and a 2, the first 2 digits, and then that the first female is a 123, so they put a 3 here. Now, there's also a female that's in the 120s also. She happened to be 125. So it puts a 5 next to that. If there would have been 126, there would have been a 6. If there were 3 126s, it would put a 666. So those single digits represent the frequency in that particular row of 120 pounds or more. And for 130 pounds, there was only one person. So that was 134. For 140 pounds, there were 2 people, 145, 146. So this stem and leaf plot kind of is a mirror, sideways mirror of a histogram, right? So it's kind of silly. The reason why this is kind of a legacy thing, and SPSS always does this on every Explorer analysis. Imagine back in the days before they had computers that easily did graphics, this would be a way to create a histogram by using just numbers, like letters and numbers and stuff like that. So you'd be able to visualize the data without the capability of actually drawing a graph in the software. Okay, and it's doing the same thing for males. Right? Okay, and there's a box plot. Anybody remember what these values, what the feathers or these little light-colored lines stand for? Right? Yep. Yes. Well, yeah, whiskers. Right. Exactly. Well, yeah, whiskers, feathers. I don't know. Yeah. Right. On either end of it, in this case, they're the lowest weight for the male. This is the males, obviously. They're the lowest weight and they're the highest weight. Right. That's not always true. Right. I kind of threw that out last week also. Sometimes if you have a value that's so far away from the mean that it's more than 1.5 interquartile ranges away from the mean, all the way out here, then the feather would represent, depending on how the software works, it would either represent the next highest value or that the distance that's 1.5 interquartile ranges from the mean. You'd really have to test, to check how this is handling it. I'd really have to test it with a data set to know which one it was, because it would be pretty easy for you. In this case, we don't see any asterisk circle outside of these ranges, so there's no outliers and no values that are so far away that they're 1.5 interquartile ranges from the mean. Maybe I should have defined interquartile range before I said that, right? Okay, so here we got the minimum value for males and maximum weight for males. Okay, now we have a box here, grayed out box. The bottom of that grayed out box represents the 25th percentile. In other words, if I bring this over here, that looks like it's somewhere about 156 pounds or something like that. That means that 25% of the population or sample is below that value and 75% is above it. The top of this box is the 75th percentile. That means that 75% of the people in the sample are below that and 25% are above that. Just as when you took the GREs, everybody here was in the 85th, 90th, 99th percentile, right? So that means that that percentage of people that took the test were below you, right? So this grayed out box represents the 25% of people are below, 25% above. So it represents the middle 50%. Kind of a way of getting a feel for where the center of this distribution or this sample happens to be. Okay, and we don't see it here because the median value, the middle value for males, we'll take a look at that in a second, is either pinned against the bottom or the top, either it's at the 25th or 75th percentile. We'll see when we take a look at it. But let's take a look at the females. The median, and in fact, this is the median, not the mean, right? It's the middle value, the middle person. It's basically in the middle of this distribution. That's what we would expect, that the middle value is going to be in the middle of this interquartile range, or 50th percentile. right? When it isn't, it suggests to us that, let's say it's on the bottom here. That suggests to us that the top part is more spread out than the bottom part is. In other words, if we plotted this with a real histogram, it would look skewed, right? It looks bent over like that, so that people at the top are spread out further away from me. Okay, so that would be what skew would look like on a box plot. Okay, so let's stop for a second. Any questions? No questions? Nothing? Okay, everybody happy with this? This is pretty easy, simple piece of software to use, right? How many of you have yet to download? Haven't downloaded it yet? Okay. Do you plan on? Or you're going to use R? How many of you guys don't plan on? You're going to use R instead? Okay, we're going to talk about R a little bit. I'm not really going to get into it tonight. I'm going to give you plenty of resources for it. And I'm thinking maybe I'll go through one of the courses as well with you, and I'll maybe do a demo, maybe over the weekend or something like that. We'll do